All right, now in this video, these that were given are quarter cycles only. So because they're only quarter cycles, we have to really think about which 1/4 or 1/4 of the graph is given to us. Again, we're looking for the rounded end and the straight end. And so going back to our sine and cosine graphs, we really need to look at what 1/4 of the cycle are we given? Are we given a piece that's below the sinusoidal axis going from a min, or between a min and a sinusoidal axis point? Are we given one that's from a max, right, down to a sinusoidal axis point? There should be some telltale sign that there is a max or min at one of the two endpoints, okay? And a sinusoidal axis point that's at one of the two endpoints. Here I can definitely see more curvature here. So I know this is a max. Here I see some more curvature at this end versus the other end, the left end. So this is our min. Okay, we can see some curvature each way. Okay, definitely because this is very straight here, and straight here at these endpoints. Those would definitely be points on the sinusoidal axis instead of a max or a min point. They would have to be a sinusoidal axis point because there is no curvature for showing that max or min point. So those are just two options of what we could be seeing. Back on our graphs that were given, let me look at these two choices, right? One of these two endpoints has to be a max or a min because it's 1/4 of the cycle. It's going between either a max and min and the sinusoidal axis. So this one I'm going to call a min right here. This one I'm going to call on the sinusoidal axis. Okay, right there. So I can see the curvature down at the right end point, so I can see that's definitely a minimum. Same thing here, I can see this is definitely a minimum versus this one. It would not be a max because there is no curvature up there at the top. It would be a sinusoidal axis points. Okay, that point would be on the sinusoidal axis. So when I go to try and find the equations of this, it would help me to then draw the rest of the graph. So I'm going to see this sinusoidal axis point here at y equals 2. This minimum point goes down here to, or sorry, -2. The minimum goes down to -6, I believe, if I drew that anywhere near straight. Okay, so since those are 4 apart, then my maximum has to be 4 above that sinusoidal axis. The maximum line has to be up here at 2. So if I go back and forth, I have to decide right away whether I want this to be a sine or a cosine. It really doesn't matter because either one will work for me. I can see the rest of the bottom of the graph would go like to here-ish. And then I have to decide whether I want to go 2 quarter cycles back or just 1 quarter cycle back. If I go 1 quarter cycle back, I would end up at a maximum point, and I could use this as a cosine. Or if I didn't want to go back, I could, or forward a little bit, I could go backwards a little bit more and start it right there, and it could be a sine graph, okay? But I have to look at what I'm given here, okay? So let me back up a second. I want to find those points more accurately, okay? So those 2 points that I'm given, my sinusoidal axis point right here, let's figure out some x and y coordinates for those. It looks like at about, okay, so those tick marks on the x-axis go up by 5s, actually. So that looks like it's at about 30, comma, -2. And then this minimum point, what do we think that one is at? That's probably at 40, comma, -6. Okay? So if I go and find some more points then, going over to this next point, since there's 10 degrees between them, I'm going to go another 10 degrees over and end up on the axis here again. So this point's going to be 50, comma, -2. Let's say I want to do sine, so I'm going to put this another 10 degrees back and end up right here at a max point. So 20, comma, 2. And then back down to the sinusoidal axis over here at 10, comma, -2. So it's all kind of squished in there, but you can see where I have 1 full cycle of the sine graph. Okay, so I look for the sinusoidal axis. Okay, my sinusoidal axis here is that middle line at y equals -2. My amplitude is how far above and below I go. That's 4 above and below that sinusoidal axis. My phase displacement, okay, how far am I starting over, or where's my starting point, right? That phase displacement is my shift. Instead of starting at 0, it starts at 10, okay? And then my period will help me out here. It takes from 10, it starts at 10 degrees and goes up to 50 degrees. So a total width of 40 degrees. Okay. The 40 degrees, though, doesn't go into the equation. The 40 degrees helps us find that horizontal dilation. Okay. I know it's getting skinnier, so I want a fraction that's less than 1 because it's getting skinnier. So I compare 40 and 360. I'll take 40 divided by 360, because 360 is the usual period of sine and cosine. Okay? And when I reduce this, I get 1/9. Okay? So my dilation factor is 1/9 because it's getting skinnier, but then in the equation I'll just use 9. Right? So using all these pieces, write the equation. Sinusoidal axis, -2 plus 4 cosine. Oh no, I was using sine, wasn't I? Undo. Okay, sine of 9 times theta minus 10. Okay, so I have my phase displacement of 10 degrees. When we get to the right 10, I've got that dilation horizontally of 1/9, but in the equation I use the number 9. Right, the reciprocal goes in there. So that is our equation for this quarter cycle if I'm going to use sine. I could have also used cosine, but the only number to change here then, other than using cosine versus sine, the only number that changes then is that phase displacement. That period should still stay the same, so the horizontal dilation should still stay the same. The amplitude and sinusoidal axis would not change. The only thing that would change is that starting value. Okay? Instead of starting it here, I would have started it here. Okay? It would end right there then at 60, 2, and it still would go from 20 to 60, still have a period of 40. So in this case, my phase displacement wouldn't be 10, it'd be 20. So phase displacement for sine would be 10 degrees, but 20 degrees for cosine. Okay? So if I wanted to write a cosine equation, like I said, it would look very, very, very similar. Okay? Those would be the only changes, changing from sine to cosine and changing the phase displacement from 10 to 20 because you have a different starting place if you're using sine versus cosine. Either one of these would be acceptable. Back of the book would maybe have one or the other, or the answers would have one or the other, but either one is acceptable as long as it still graphs the exact same graph. I'll make that a little smaller here. All right, so second try at our next one here. Okay. Sinusoidal axis was up here at, looks like 3. Minimum was down here at -2. So since those are 5 between, I know I have to go from the min to the sinusoidal axis is 5. I need to still go 5 above that. So up here to 8 should be where my maximum hits at. Okay. Let me go forward another point, right? Let's see, is that, let's see, these are going up by 5s again. So 55, -2 is our minimum point. Our sinusoidal axis point looks to be at 75, 3. So there's 20 degrees between them. So I need to go 20 degrees farther to get up to my max. That would be at 95, 8. Okay, that's our max point. Okay, going back another 20 degrees would be here on the sinusoidal axis again. This would be 35, 3. Maybe going another 20 back would be at 15, 8. So since I've already gone to there, let's say I'm doing a cosine for this one. Okay, I can see my cosine. So sinusoidal axis, that's y equals 3, amplitude, 5 above and 5 below that, I get 5 for my amplitude. Phase displacement, again, if I'm using cosine, that's going to be 15 degrees, okay? and then period. Okay, it starts at 15, it goes to 95, subtract those, I get a period of 80 degrees to go through one full cycle. Okay, so my horizontal dilation, again, I made it smaller than the regular period. So I don't want this number to be less than 1. I compare 80 and 360. Let's see, that's 8 over 36. That's 4 over 18. That's 2 over, oh, there we go. 2 over 9. Completely simplify that all the way down and I get 2 over 9 is my horizontal dilation. So when I write the equation, sinusoidal axis 3 plus the amplitude, cosine I was using here. The 2/9 was my dilation horizontally, so I put 9 over 2 here. Theta minus 15 degrees, since we're using cosine. If I wanted to use sine, all I would need to do is back this up one more point to start on the sinusoidal axis going up, and this new starting point would be 20 back from that would be -5, 3. So if I wanted to use cosine or sine instead of cosine, my phase displacement would be -5 degrees for sine. So rewriting this in terms of sine, the only thing that changes is this phase displacement that goes in here. Since the phase displacement was -5, I had to move it left 5. This would be +5 degrees like that. And again, I would take either of these as your answer. You don't have to have both, just one or the other.